we're broadcasting live on YouTube. All right, how is everybody doing? I already asked some of you that this morning. I know that Elijah's good. He's had his coffee. And Caitlin and Greg. You got all yours done? Awesome. I like it. Okay, so does anyone have any questions that they want to go over from anything? Chapter 4, Chapter 5, Chapter 1? I have not graded the test, though, yet. Elijah asked how the test was. I have not graded the test yet. That is on my agenda if we get the if we get done early. The quiz, the Chapter 5 quiz, should be easy peasy. So any questions, or we just want to get this done? Let's get it done. All right, that sounds good. All right, so I thought what we talked about on Friday, just to kind of review, is Chapter 5 is a quick little section. 5.1, I think you guys all did 5.1 already, right? So we're talking about polynomials and polynomial functions. So 5.1 was a review of exponents. 5.2 was just kind of a quick, easy section about solving basically polynomials. That was pretty easy, right? And then 5.3 is also a review of your Algebra 1 days. Just keeps coming back, right? Oh, you're done with 5.3 already, Elijah? Well, I'm going over 5.3 today. So that's a good thing. Yeah, so they should be easy sections. So that's a good thing. So what we talked about on Friday in 5.3, we even started 5.3. So the first thing we talked about was adding and subtracting polynomials. So remember, polynomial is just a really fancy name for a quadratic can be a polynomial. This is a quartic equation, right? Because it's a v to the 4th square. A polynomial is just basically a bunch of monomials that are added together. And mathematicians define it, the polynomials have squares that are positive whole numbers. So for example, I feel like I'm talking and not showing. For example, if this will let me write, I'm just going to switch to paint. X cubed plus 3x squared plus 5 will be a nice, easy to looking polynomial, right? Polynomial, and we could call this a polynomial function. If we have x to the negative 1 power plus x squared plus 2x equals 0, this would not be our standard polynomial function, right? So we're dealing with these ones that are kind of the clean looking polynomials in this section. So what we talked about on Monday was how do we add and subtract polynomials together. So since you guys are on this call Friday morning, a nice cold Friday morning, let's do one from your homework. Okay, so let's do number 5. This is from 5.3. All right, so this one, just test yourself as you're going to. Like you might even want to start doing this one and see if you get the same thing. So we have 4y squared plus 9y minus 5 minus 4y squared minus 5y plus 3. Okay, so you might want to test yourself out doing this. You might say this is easy. That's not a bad thing. All right, so what we want to do is we want to subtract one polynomial from the other. And just a reminder, you can only add or subtract like terms. I don't know if you remember that back from algebra, but like terms are the ones that basically have the same variable. So 4y squared and 4y squared are like terms. 9y and negative 5y are like terms because they both share a single y. And negative 5 and positive 3 are like terms because they are constants. Okay, so the other trick to this particular problem and why I picked number 5 is that instead of adding, we're subtracting. Okay, adding is easy peasy, right? We got number 3, 7, 9, and 13 on your homework should be cake because they're all adding problems. Just 5 and 11 are the only ones that are subtracting. Okay. So when we're subtracting, what you have to remember is this subtraction sign is out in front of everything in the parentheses. So the subtraction applies to every term in your polynomial. So in my brain, how I deal with that is I like to think I have to distribute the subtraction, oops, I'm running out of space, to every term in my second polynomial. You might think of it differently. You might be able to say, okay, this is 4y squared minus 4y squared. However you kind of work that out in your brain, just remember the subtraction applies to all 3 terms. So that's where a lot of people mess up. Usually they get the subtraction of the first term, but then when it comes to the second two, kind of falls by the wayside. So for me, how I would kind of think about this or rewrite this in my brain is I would say, okay, the first polynomial stays the same, right? The second polynomial, I'm going to get rid of the parentheses by distributing my negative. So I could rewrite this as, and I really don't even need my first parentheses here. Let's take those off. Okay. The second polynomial, I'm going to distribute my subtraction like a negative. So I'm going to say it's minus 4y squared. And then it's minus a negative 5y minus positive 3. Okay, so minus a negative is the same as adding a positive here in the 4y squared. So what we're left over with now is adding our like terms. So we have 4y squared minus 4y squared, and that's going to give us a big old 0. So that's good. Then we have 9y plus 5y, so we should get 14y. And we have minus 5 minus 3, which will give us minus 8. All right, so that's number 5. Did you guys all get that? Easy peasy. So the biggest trick to those, honestly, is when you're subtracting to remember to subtract every term. Anybody still there? All right. You guys were like, we'll just do our homework. I thought maybe you left me to go do your homework. Okay, so I think that's easy. I think you guys should be good with that. Part 2. Good. I'm glad it's easy. So adding, subtracting polynomials. Part 2 is multiplying polynomials. So this is using my favorite property. For those of you who have had me in Algebra 1 in the past, my favorite property happens to be the distributive property because it just keeps coming back. It's in math everywhere. It just keeps coming back. And I'm actually going to print screen this and pull it into Paint because I think it actually works better. All right, so multiply the polynomial. So basically, I know, Elijah, you want to say, what do they mean? Basically, you want to multiply in number 4, x times the polynomial 2x squared minus 5x plus 7. And so they want you to kind of simplify it, right? So in order to get rid of the parentheses, we get to use my favorite property, which is the distributive property. And so in this particular case, it's nice and easy. What we're going to do is we're going to distribute the x to every term in the polynomial by multiplying x by every term. So if we want to simplify this, what we're going to do is we're going to have x times 2x squared minus x times 5x plus x times 7. So then we do some simplifying, and you might not even write out all that stuff there. You might kind of have it down. You've got 2x cubed minus 5x squared plus 7x. So this original expression and this new expression are equivalent expressions. They're equal expressions. One is just written with the parentheses, and the other we have without the parentheses. Sort of, kind of. Okay, so then we get a little bit more fancy. In number 5, we have y minus 7 and y plus 6 multiplied by each other. Does anybody remember how to do that one? Yes, Mackenzie. FOIL, thank you. All right, so to do number 5, you want to FOIL, right? We can distribute and distribute again, but FOIL is just the shortcut for solving two binomials multiplied by each other. All right, so what I mean by that is I could distribute 5 minus y to each of these, and then I would have to distribute again. But back in Algebra 1, I think most of you learned, at least if you're with me, at least Mackenzie remembered, you got to FOIL it, right? You got to FOIL it in order to simplify this. Well, you don't have to. You could distribute and then distribute again, but FOIL is going to be the shortcut that we use. So FOIL stands for first, outside, inside, last. So what we're going to do is we're going to multiply the first terms, right? Y times y is y squared. Our outside terms are going to be 6 times y. Our inside terms are going to be negative 7y. And our last term is going to be 7 times 6, 42, right? Negative 42. I know. How can you forget FOIL, Elijah? All right. Y squared minus y minus 42. So what I did is I combined the two middle terms. 6y minus 7y is negative y. I know, Elijah. How could you forget FOIL? If you do forget FOIL, if you really forget FOIL, you can distribute and distribute again. So this is what back in algebra, we would say, okay, you have y minus 7. This is before you learn FOIL, and then they teach you the easier method, right? Y plus 6. So what you technically can do is distribute y minus 7 to both of these things. If I can write my y right. So you would have y minus 7 times y plus y minus 7 times 6. So you see how you distribute it? And then you have to distribute again. So you have to distribute the y here and the 6 here. So you get y times y is y squared. Y times negative 7 is negative 7y. 6 times y is plus 6. And 6 times negative 7 is negative 42. And you end up with the same thing. So FOIL, remember, is just the shortcut, so you don't have to distribute and distribute again. Okay, so then, dun, 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 what about when you get to number 6 here? This is kind of like the challenge problem. This is actually your last homework problem, not the exact one, but will be exactly like this. So number 21 on your homework. You've got w plus 4 in parentheses times w squared plus 6w minus 11. And actually what I'm going to do is I'm going to make a whole new document and make a clean copy of this so you don't have to, we've got plenty of room to work out this problem. So can you FOIL this? Unfortunately, no. Can you FOIL number 6? You can FOIL 5, right? Can you FOIL 6? Nope, can't FOIL 6 because we don't really have a, you have to have a first, an outside, an inside, and a last. So what would your, you've got a first and a last, but your inside would get pretty confusing, right? Yeah. So we actually have to use the long way of simplifying this. So just to kind of, before I just do all the math part of it, what you're basically doing is, since you have the w plus 4 is in parentheses and the w squared plus 6w minus 11 is in parentheses, you have to multiply w plus 4 times every term in the parentheses in order to get rid of the parentheses. Okay, so just like if you had w, not w plus 4, if you had w out front, how would you simplify it? You would multiply each term by w, right? But we don't have a w out front. We have a w plus 4 out front. So we're going to have to multiply every term by w plus 4. So it's actually the same thing that we were doing when you just have one term, but now we have two terms. Okay. All right, so what you're going to do is you're going to distribute the w plus 4 to each term. So you're going to have w squared times w plus 4 plus 6w times w plus 4 plus, not plus, minus 11 times w plus 4. Okay, so we took what was out front and we distributed it to every term in the polynomial. Now, how do we solve this? This is like the distributive property dream. How do I solve each of these terms? I have to distribute again. All right, so I have to distribute my w squared to each term and the w plus 4. So I'm going to get w cubed plus 4w squared. And then in my second term, I have 6w times the quantity of w plus 4. So I have to distribute my 6w. So I'm going to have 6w squared plus 6w times 4, which is 24w. And then in my last term, I have to distribute my negative 11. So I'm going to get negative 11 times w is negative 11w. And negative 11 times positive 4 is negative 44. So now I have some simplifying to do. I only have one cubed term, so I have w cubed. I have two w squareds, so 4w squared plus 6w squared is 10w squared. 24w minus 11w is going to give me plus 13w. minus 44. So this expression is the same as this one that I wrote all over. One is multiplied out. So for your homework and for doing your problems, this is the distributive property. Like, you get lots of practice with the distributive property, right? All right, so how'd that feel? You guys easy, hard, want to see another one? You felt like you were taught, but that's good. If you're being taught something you know, that's good. You're like, nice, easy section. Check it off, right? That is it. That's all I have for you. That's the end of your first semester of Algebra 2. I am happy to do any more problems that you want to see. If you want to see another example, you can do that. On Monday in class, we're going to do a group project, just to give you a heads up. So it's actually going to use, we're going to use quadratic equations, but we're all going to work together as a group. Yes, a group project with math. It's going to be fun, Elijah. Okay, fun for math, right? Yeah, so on Monday in class, we'll have a group project that we're going to work on, and I will enter that. If you guys all participate, I'll put that in as another homework grade. So just something you don't know about being fun with quadratics. All right, so maybe I shouldn't tout it as fun. Maybe I should just say it's a group discussion project, and if you just participate, then you'll get points, full points for your homework grade. And my home phone is ringing. So any questions about what we have left? Any homework? You guys good? You ready to go finish up your stuff? If you want to turn everything in on Monday, I would encourage you to do that, because then you can say, I'm done with math for the year. Awesome. I'm glad that you're swell. I think everybody knows what's going on. 5-1 through 5-3. There's a quiz I sent out on Monday. Group project next Monday. I probably have some cookies for you guys or something to eat. It'll be pretty relaxed. All right, well, that is it for today. If you guys don't have any questions, I'll stay on for a few minutes to answer anything you've got. And then I will be grading your tests after I get off the phone, after I get off the call. All right, I am going to turn off the YouTube video here. Let's see.